Efficiency. What can be said about the efficiency of big Y bar? Suppose efficiency entails a expression of estimators. We need to specify the estimator or estimators to which big Y bar is to be compared. We start by comparing the efficiency of big Y bar to the estimator of big Y sub 1, because big Y sub 1 through big Y sub n are independently and identically distributed. The mean of the sampling distribution of big Y sub 1 is the expectation of big Y sub 1 equals mu sub big Y. Thus, big Y sub 1 is an unbiased estimator of mu sub big Y. Its variance is var of big Y sub 1 equals sigma sub big Y squared. From section 2.5, the variance of big Y bar is sigma sub big Y squared over n. Thus, for n is greater than or equal to 2, the variance of big Y bar is less than the variance of big Y sub 1. That is, big Y bar is a more efficient estimator than big Y sub 1, so according to the criterion of efficiency, big Y bar should be used instead of big Y sub 1. The estimator big Y sub 1 might strike you as an obviously poor estimator. Why would you go to the trouble of collecting a sample of n observations only to throw away all but the first? And the concept of efficiency provides a formal way to show that big Y bar is a more desirable estimator than big Y sub 1. What about a less obviously poor estimator? Consider the weighted average in which the observations are alternately weighted by half and 3 over 2. Big Y tilde equals 1 over n times open 1 half big Y sub 1 plus 3 halves big Y sub 2 plus 1 half big Y sub 3 plus 3 halves big Y sub 4, all the way through, continuing to 1 half big Y sub n plus 3 halves the last term after the following ellipsis plus half big Y sub n minus 1 plus 3 halves or 3 over 2 big Y sub n. Equation 3.1. Redoing equation 3.1, big Y tilde equals 1 over n open 1 half over 1 half Y sub 1 plus 3 halves Y sub 2. Oh my goodness. 3.1, big Y tilde equals 1 over n open 1 over 2 times big Y sub 1 plus 3 over 2 times big Y sub 2 plus 1 over 2 times big Y sub 3 plus 3 over 2 times big Y sub 4 plus ellipsis all the way through 1 over 2 times big Y sub n minus 1 plus 3 over 2 times big Y sub n. Close. Completed equation 3.1, where the number of observations n is assumed to be even for convenience. The mean of big Y tilde is mu sub big Y. The mean of big Y tilde is mu sub big Y, and its variance is var of big Y tilde equals 1.25 sigma sub big Y squared over n, exercise 3.11. Thus, big Y tilde is unbiased, and because the var of big Y tilde approaches 0 as n approaches infinity, big Y tilde is consistent. However, big Y tilde has a larger variance than big Y bar. Thus, big Y bar is more efficient than big Y tilde.